Let's take a look at how we can use the unit circle to find an exact value for tangent of 29 pi over 6. The unit circle is often a shorthand for the special points on the unit circle. The unit circle really is a circle of every point that is 1 unit away from the origin. But these special points are nice because they have exact trigonometric function values. Their coordinates, I should say, correspond to exact trigonometric function values. So to use the unit circle here, the first thing that we need to do is figure out a coterminal angle for 29 pi over 6, because that doesn't appear as one of the angles on the unit circle. If our angle was one of the special angles on the unit circle, then I wouldn't need to do that, but since it's not, let's think about how to do that. So 29 pi over 6, we might make a conjecture here, and it's true, it's going to correspond to one of the multiples of pi over 6. So it's going to correspond to either pi over 6, 5 pi over 6, 7 pi over 6, or 11 pi over 6, because 29 pi over 6 is in simplest terms. I can't divide anything, I can't divide 29 by 2 and turn the denominator into 3. Or anything like that. So it's going to correspond to one of those places that have a denominator of 6, but let's think about which one. Well, I can find a coterminal angle by adding or subtracting 2 pi. But in this situation, I want to think of 2 pi not as 2 pi, but I want to think of it as 12 pi over 6. And so if I subtract 12 pi over 6 once, I'm left with 17 pi over 6, taking 12 away from 29. And if I subtract 12 pi a second time, we get 5 pi over 6. So 5 pi over 6 is the angle that we're interested in. That's the angle that's coterminal to 29 pi over 6. So at this point, we have sort of two options. If you're comfortable with the coordinates of the unit circle, one option would be to find the coordinates of the unit circle at the point that we're interested in. And so we could do that. It turns out the coordinates here are negative square root of 3 over 2 is the coordinate for x, and 1/2 is the coordinate for y, and that may be familiar and kind of a comfortable way to go. If we have the coordinates, of course, if we have the coordinates, the first is the x coordinate, the second is the y coordinate, and tangent is equal to y over x, and so we could use these coordinates to find the tangent value. I want to suggest a second, slightly different method would be to place a special right triangle on the unit circle. And I put the unit word there in quotes because I don't necessarily want to focus on that. There's a certain shape here. I'm interested in this angle, and it turns out that the reference angle is going to be pi over 6. In fact, all of the places that have a denominator of 6 have a reference angle of pi over 6. That's the same as pi over 6 is equivalent to 30 degrees. And so I can place a 30, 60, 90 right triangle in here, and that helps me identify dimensions. So if I think of this as a unit circle, then the hypotenuse would have to be 1, but because it's somewhat more convenient, I could think of that hypotenuse as being length 2. Of course, that makes these coordinates not really appropriate anymore, but it makes values a little bit easier to work with. So if I think of that as 2, and then the y value would be positive 1, and the x value, because we're in the second quadrant, should be negative 3, negative square root of 3. And from that, we could do the same work here to find the ratio that we're interested in. I want to take the y coordinate of 1 and divide by the x coordinate. We would get a similar answer by taking the coordinates from the unit circle, but things get a little bit more complicated because it would be 1/2 divided by negative square root of 3 over 2. And then we'd have to think about simplifying. Of course, if I multiply both of these fractions by 2 over 1, the 2's cancel, and we get 1 over negative root 3, or rationalizing the denominator, negative square root of 3 over 3. And so either way, those are the exact expressions for our answer, either 1 over negative square root of 3 or negative square root of 3 over 3. So the important thing is to practice and think about the method that you're most comfortable with and use that to solve problems. So let me end the video with a question. Using one of the methods, or maybe even better, using both of these methods, try to find an exact value for secant of 13 pi over 4. I encourage you to take a few minutes and think about that. I hope you enjoyed the video. Thanks for watching.